Won't you take me to Function Town? Won't you take me to Function Town? In our last video, we talked about functions and how to determine if something is a function or not using the vertical line test. And just as a reminder, what is a function? Well, a function is technically defined as each element in the domain corresponds to exactly one element in the range. And now we can simplify that further. We know that an element in the domain is just an x value, corresponds to exactly one element in the range. All right, so element in the range could be y value. And this is just a fancy way of saying for each x there's only one y. Now what we're going to talk about in this video is function notation and how to evaluate a function. So I'm sure at this point you're familiar with an expression like y equals 3x minus 2. When we move to function notation, instead of using y, we use this notation f, and we read this f of x equals y. And what does this mean? Don't overcomplicate it. Wherever I have a y, I can stick in f of x. Okay, so we read it f of x, even though it's f parentheses x close parentheses. So now instead of writing it this way, I'm going to write it f of x equals 3x minus 2. Now, it's important to remember these are exactly the same thing. This is just expressed in terms of x and y, and this is expressed in terms of our function notation. So why do we move to function notation? To confuse students, of course. Just kidding. All right. Well, one of the advantages is I can now name my function. So out here, the f in front is its name. Okay. So now, I don't know about your parents, but my parents named all the kids different names. And you're probably laughing right now, but George Foreman did not. He has like George the First, George the Second, George the Third, all the way up to George the Fifth. So what happens in George Foreman's house is if he yells George, all the kids come running. But what happened in my house growing up is my name is Shannon and my brother's name is Bob. And when my mom called Shannon, I came. And when my mom called Bob, my brother came. Pretty simple. So if we assign a name and we say f, we know to use this function. And similarly, I can make another function. And if I say to use g, okay, because this letter out here, or letters, is the name of my function, then you would know to use this function. Okay, so first of all, function notation lets us name our function. And second of all, it helps us to evaluate it. When we were using this type of notation, I would have to write out evaluate when x equals 2. Now, if you've never seen the word evaluate, we think of that as plug it in. Okay, I always think about the Glade plug-in commercials. Plug it in, plug it in, plug it in. Plug it in, plug it in, plug it in. So whenever we see evaluate, we're going to plug something in. Okay. So in this example, we would go to our expression, and wherever we have an x, we're going to plug in 2. So we would say that y equals 3 times 2 minus 2. Continuing our evaluation, 3 times 2 is 6. Minus the 2 would be 4. And all that's great, but I have to write this out every time. In function notation, if I want to evaluate something when x equals 2, because that's my variable in here, if I write f of 2, that's what it means. Here is my variable. Here I've replaced it with a 2. So the way we read this, we go to our f function. That's where our name comes in handy. We don't go to g because I'm calling f, right? My brother didn't my brother did not come when my mom called my name. Okay, he probably went the other way. So when we call f, we go to the f function. Wherever we have this variable, we're going to plug in this number. So this would mean 3, 2, minus 2. 3 times 2 is 6, minus the 2 is 4. And so you can see that we've expressed this entire statement here, evaluate when x equals 2, with just this notation, f of 2. All right. Let's try another one. We could say g of negative 2. Okay. Well, now I've called g's name, so I'm going to go to the g function. And wherever I have my variable, I'm going to stick in this number. So this would be -2 squared minus 4. Now notice if the square is attached to the variable, if we plug in for the variable, the entire thing gets squared. So this is -2 times -2, which is a +4, minus the 4. So we would say 0. Okay? And now they can get a little trickier. So I might say f of a plus 4, all right? But don't overcomplicate it. This still means go to my f function. Wherever I have my variable, I'm sticking in this whole thing, a plus 4. So I would still have my 3. In place of x, I would put a plus 4, and I'd still have my -2. Okay? Simplifying that, you can see I can distribute the 3. I get 3a plus 12 minus the 2. Okay? And now continuing, by combining my like terms, I would end up with 3a plus 10. And now I can't simplify that any further. Okay, so this would be my answer. All right, so again, function notation. We simply replace y with f of x. And the advantages to that is we now have named our function, and we can have a whole list of functions with different names. And it helps us evaluate the function. Instead of writing all of this out, I can now put f of 2, which means go to my f function, wherever I have my variable, stick in 2. Now, the last thing I want to talk about in this video is how to evaluate using a graph. So I have 2 graphs here. Okay, I've named my function f. Let's pretend that it keeps going and put some arrows on there. All right, so now if I want to find f of -2, all right, remember what that meant from before. My variable is x, so I'm saying x equals -2. Now, I like to think of this as a hunt and find. I'm giving you the x value, you give me the y. In other words, there is a point on this graph that has an x value of -2. What we're looking for is the y value for that point. So what am I going to do? Well, the -2's in here, so I'm going to start off by going to x equals -2, right? That would be right here. I'm going to go to my graph, and that's the point on my graph. So I know the x coordinate's -2. I gave you that information. What you need to give me is the y coordinate. And you can see here, this point is -2, 6. So what we write this as is we say f of -2 equals 6. Okay. All right. Recall that we say f of x equals y. So if I give you this x value, you give me the y value. All right. Let's try another one on this graph. Let's do f of 0. Well, that means x equals 0. I'd find it right here on the origin. I'm going to go to my graph right here and read off the corresponding y value, which is right there. This is going to equal 2. In other words, the point 0, 2 is on that graph. Okay, we write it like this, but you can think of it like this. All right. All right, let's go down here and do a different graph. Here I'm calling this one G. Okay, see that name? All right, and now let's find G of 0. In other words, x equals 0. I'm going to go here. I'm going to go to my graph and read off the y value, which says that this is 5. In other words, the point 0, 5 is on this graph. Okay. All right, let's try f of G, sorry, because we're dealing with the G function, -4.5. All right, so we're going to go x equals -4. 4.5 is in the middle. I'm going to go to my graph and read off the corresponding y value, which is -15. All right, I hope you've enjoyed this trip to Function Town, and I hope now that you can learn a little bit more about function notation and how to evaluate functions using either the formula or the graph.